competition has started, and we see FIU's robot off and running, and there goes Auburn. I saw Auburn move. Drive it like you stole it, FIU. FIU has a track system in order to move their robot. The Auburn team chose to put 4 wheels on the robot, but these are not normal wheels. These wheels have foot pads. So Auburn is trying to use a stepping concept where their robot steps across the regolith. Let's see how well it works. Seems to be working well. Auburn is halfway across the obstacle field. These teams have to get their robots across the obstacle field all the way past that orange line in order to get their robot into the digging. There, Auburn is into the digging area. Now they can start digging. There's their ladder bucket. Their conveyor belt is digging. This is the lander view for Auburn. This is the view that the students can see while they're controlling their robot. The students are controlling their robot from the enclosed trailers behind us. They cannot see the robots except through these video feeds. That's a look at Florida International University's robot. It hasn't moved in a while. That's Auburn's robot. Hard to tell from this reverse angle what's going on, but that's the angle that the students can see. This is this view that the FIU students can see of their robot. If they've got something going on the other side of the robot, they can't see that from this camera view, but that's the only camera view NASA gives them, because that's the camera you would have on a lander if this was a real mission to another planet. FIU's bucket is not having any trouble moving. Alabama's conveyor belt is flipping some regolith up in the air. Hard to tell from this view whether it's making it into the robot's bucket. FIU may be trying to get their robot moving by bringing the bucket down. This is how FIU's robot deposits regolith into its own bin. Backwards like that. 6 minutes remain in this competition. Auburn University and Florida International University. Auburn on the left, FIU on the right. You can see Auburn's conveyor belt trying to dig. You can see Auburn's wheels spinning. FIU demonstrating their dumping mechanism there on the right. They may be stuck, folks. Five minutes left in this run. These teams have been here all week long. This is B2 control room. That's FIU. They haven't given up. They're still trying to control the robot. There's Auburn's robot. The students can control this camera. They can zoom in. There's control room B1 where Auburn University students are looking over the situation. Minutes remain in this competition. Each competition run is 10 minutes long. The idea is to go across the obstacle field and dig as much regolith as you can, carry it back to the starting position, and dump it all into the hopper. If this was a real NASA mission on another planet, this regolith might have molecules in it that are useful. If it's icy regolith, it would have oxygen and hydrogen that's useful. We could turn that into rocket fuel. Or there might be some heavy minerals in the regolith that we could use for constructing structures. That's a close-up view of Auburn's robot. 3 minutes remain. Neither of these robots have moved very much in a while. Although they have not given up trying, you can see Auburn's wheel spinning right there in this camera view. We could never put on a competition like this without sponsors. Our main sponsor is Caterpillar Incorporated. Thank you, Caterpillar. We also have sponsors. We have Harris Corporation, Honeybee Robotics Corporation, Lockheed Martin, Moon Express Incorporated. Thank you to those sponsors. We're also getting help from IGUS Inc. and Space Florida. And this venue, right here where we're sitting, this is provided by the Kennedy Space Center Visitor Complex, run by Delaware North Parks and Resorts. Thank you, Delaware North. We can't do this without a great venue like this. And we also want to thank the Astronauts Memorial Foundation and Secor Strategies. We cannot do this competition without lots of help. Not to mention all the NASA and contractor volunteers that have volunteered to help run this competition to make it run smoothly. My name is Kurt Lloyd, and I'm proud to be hosting the 2015 NASA Robotics Mining Competition. I'm a NASA engineer by day. This is not my day job. This competition is nearly complete. Sadly, neither robot was able to mine and deposit regolith into the hopper. But it's not a total loss. These teams have learned a lot in the past year, designing these robots, building these robots, bringing them here to compete.